Hey, how's it going? Yeah, so I've heard a lot of people talking about, encrypted radio for a long time. How to get it, what you can do with it, the legal ramifications, all of that sort of stuff. And for a long time, the go-to sort of non-encrypted radio for budget users was the Baofeng. They make a few models, but, you know, they are kind of just bottom of the barrel radios, and they get the job done. You can get a good like 5 miles of range, 5 kilometers, maybe 3 miles in any sort of like urban environment. But yeah, there's always been this big concern that it's not encrypted and you're putting out this huge amount of signature. If there's ever any concern about people listening in or triangulating, it's pretty easy. So yeah, I think there are valid concerns around using this. Technically, you need a ham license, so I know a lot of people don't do that, but legally speaking, it is required to use a lot of the bands that are accessible on that radio. Another device that people have been turning to lately is the Meshtastic. Kind of a different role historically, usually focused on text. Sometimes you can send your location on any sort of team awareness kit software. That's kind of like a new thing, like the plugins and everything. But yeah, you were limited to no voice on Meshtastic. So you would have to basically run a Meshtastic for text and for any sort of environment where you need to send your voice ASAP. You don't have the time to text out a message. It just wasn't useful. It has its place, but it was limited. There's been a lot of talk about expanding voice into Meshtastic, but that it hasn't happened. They've been talking about it for a long time, the community. So I was kind of getting tired of waiting, and I just built it myself. I mean, this is with duct tape and super glue to keep it kind of a little bit waterproof. But yeah, this is basically a traditional Heltec V3, so it's like one of the cheaper ones you could get. Has a screen and a lightning port, but this is a Meshtastic device that's been converted into speech. So using Codec 2, which is like the WhatsApp audio encoding software, super easy, super light to run on this compute. Like, it's a very small board with not much compute. So very, very power conservative, I would say. This lasts around 48 hours to 72 hours, depending on usage, on a single 3000 milliamp battery. So yeah, all this in was like $45. And I built it myself just from buying the speaker. There's a mic as well, but the board came with it. And then this is just any sort of antenna works. And yeah, so this is a functioning Meshtastic device. We're getting a little bit of interference because of everything so close together, but I'll do a quick test for you. So this is a speaker, this is the mic, this is a little animation I have kind of telling you what state you're in. So if you can tell, this is like kind of an idle mode. And then once you're broadcasting, you have a little cue. So I'm gonna put the speaker here so you can listen. And I'm gonna play a transmission real quick to test it. Hello, test, Alpha, Bravo, Charlie, Delta, Echo. You can see the audio is a little fried. That's not anything to do with the bandwidth. That's everything to do with the shitty hardware. I basically put in the cheapest mic and speaker that's compatible, and I soldered it myself, and pretty new to all that. So yeah, it's kind of bad. But on YouTube, there's been a lot of demand for encrypted radio, and this is encrypted. This is encrypted, totally legal, unregulated audio over Lora. This works. I tested it out to 500 meters in urban, so through a building. The quality kind of drops off at around 250 meters. So it's like, 200 yards. Like 300 yards, whatever it is. I can never do the conversion. Yeah, so, obviously not the range of this guy by any means. And it's not the form factor. That's actually a real benefit. This is significantly smaller. You can't really picture it well, but without all this big duct tape and super glue and whatever, it would be about the size of the battery pack. So if I pull this out, And yeah, actually I can't pull it out, but whatever. The size of the battery pack of a Baofeng, you have a device with longer battery life and encryption. So in this configuration right now, we're at limited range, and that's on purpose. We're using what's called SF6. Lora is kind of broken into spread factors. The long and short of it is that as that number descends, so you go to SF6, SF5, you get more usable data on the bandwidth. So that means you can send bigger messages, a little bit like with your phone, if you're sending like a text message versus an audio message, but you get diminishing range. And it gets a little bit more finicky. So as you lose data, if it gets, corrupted or whatever, more and more of the message gets destroyed. So scaling up to SF10, that's usually the spread factor used for most Meshtastic devices, if you're familiar, when you're sending text and whatever. Those are really small messages, and they use like a preamble to kind of ID the device, build the connection before you start receiving the message. So yeah, those devices really traditionally can only run text because of how small of the allotted data that's available for that transmission. But moving forward, there's some pretty compelling ways to get this basically to run like a traditional Meshtastic device. So that means no speaker, no mic. Basically, you don't even need a screen. It's just the board and a battery and an antenna. That could fit in a standard phone case, which is what I'm planning on doing with this. And the way we get there is by getting your audio, your speech, to even smaller data. So with this encoding software, with Codec 2, you're pretty limited. There's a very steep decline in audio quality as you encode further and further down. And there's a big concern with Meshtastic around clogging the stream, clogging the bandwidth, because when messages overlap on Lora, they destroy each other. So the more of the bandwidth you take up, the less usable the whole system becomes for everyone. And that is a concern. That's why you really shouldn't run Codec 2 for any sort of larger spread factor, because you're destroying the signal for a larger and larger area as you take up more and more of the bandwidth. So a way to get around this is to leverage what a lot of AI is doing right now with audio encoding. Facebook, Meta has been pioneering a lot of audio encoding with Lyra, and that's accessible. There's also some experimental ones called semantic codec. There's one, they're all neural, meaning there's like an actual AI breaking down the audio and then rebuilding it on the other end. And this is a lot better. You preserve a lot of the quality of traditional, as compared to traditional audio encoding. And the main loss is in compute and power and a little bit of latency. With this, there's almost near zero latency. But with Lyra, with neural encoders, you're gaining around 50 to 100 milliseconds of latency. So, it's not nothing, but I don't think that's a make or break by any means. I don't think this is not a phone call. This is short voice messages in emergency situations. And what that allows is also for these radios to be on the same bandwidth as standard Meshtastic devices. So your ATAG plugins, your team awareness kit, anything that you need to send data with, you can also just use this device. While you're not sending audio messages, you're sending text messages, you're sending locations, you're sending casualty cards, you're sending any sort of team awareness kit information off your phone, and that's really the next move, right? These devices come stock with Bluetooth enabled, so on your device on your phone, you're going to run the neural encoder through an app, and that converts your audio into a much smaller data stream, which then over Bluetooth goes to your device, which then sends it over Lora. So this, you strip away all the mics, all the speakers, the screen, and you're left with literally just a funnel of information, of Bluetooth information into Lora. So you're gonna get around double the battery time, I'd say. So yeah, that's a significant advantage. You're at, I don't know, let's say, to be conservative, let's say 72 hours of battery life. With constant use, constant pinging, constant use. and you have encrypted audio, and it's plugs directly into all ATAC enabled devices and potentially future ITAC enabled devices. So anyone with a phone really can't be cut off unless they're getting actively jammed. And by that point, there's a lot of things going wrong. And this isn't just for like preppers or whatever. Like, this is for people who are interested in radio, interested in first responder stuff, agencies looking for ways to communicate. This is significantly less expensive, right? Especially future iterations would just be software, and the device and the battery are marginal. It's $40. With a 3D printed phone case, is really not expensive. It's sub $100 for encrypted audio. These Motorola's and whatever, even a Baofeng, like a shitty Baofeng, this is more expensive, and you're getting less capability. You could even run multiple Lora modules on this. If you're concerned about your transmissions being picked up by other people, you can scale the spread factor down to essentially reduce your signature. There's a lot of interesting things you can do with this, and all of it can be just software enabled. That's a huge advantage, and I'm going to keep working on this and expanding it, but I'm just a beginner. So if you guys have any comments, anything, any notes, I understand this might be controversial, and this isn't a product. I'm not trying to sell anything. This is just research. I understand there's concerns about clogging the Lora bandwidths and making the system unusable for everyone else. So I'm working on correcting that, making sure that doesn't happen, trying to get our audio transmissions as quick as possible so it can flow with the rest of the Meshtastic devices. This is all open source. The GitHub's down below. You can run it yourself. I'm working on the app right now, so yeah, that should make it a lot more accessible, because then you don't need any new hardware. Anyone with a Meshtastic device can then run audio. And I probably will start with low spread factor just to avoid destroying the system and really minimizing your transmission time at the cost of range. But that's a software change. That's really quick. With a quick flash, you can really correct that. So yeah, let me know what you guys think. Thank you.